Right. Hello. In today's lecture, we'll continue with geometry. You remember that's what we started with. We looked at two-dimensional and three-dimensional shapes. That's geometry, therefore, is the study of two- or three-dimensional shapes and their properties. That's what we had discussed last time. However, today we'll move a step further and give it some of the other mathematical definitions that regard what we have already discussed, that is two- and three-dimensional shapes. We'll look at what is called in mathematics as Euclidean geometry. It is the study of two- and three-dimensional shapes that is predominantly done in schools. So you as teachers, therefore, would definitely be dealing with Euclidean geometry, though you don't tell children that we are today looking at Euclidean geometry. You may mention the name, well, today we're looking at shapes, and this is called geometry. It's a study of diagrams and shapes and lines and so on. However, you need to know that that is, in essence, Euclidean geometry. Euclidean geometry was really a study that was done by a Greek professor, a mathematician, a long time ago. His book called The Elements, he looked at five postulates of geometry, and in it, therefore, are the properties of two-dimensional and three-dimensional shapes. So that's what we'll be looking at, which is Euclidean geometry. In Euclidean geometry, therefore, we're dealing with there are two types of Euclidean geometry. The first part, we are again going back to what we have already discussed. However, we are giving them new mathematical terms now. What we call plane geometry, which is the study of two-dimensional shapes and their properties. And if you recall, when we looked at two-dimensional shapes, we looked at triangles, which were the three types of triangles: isosceles, equilateral, and right angles, and so on. And we also looked at quadrilaterals, which are four-sided shapes, flat shapes. And in quadrilaterals, we had rectangles, square, kite, rhombus, trapezium, and parallelograms. All these were classified under quadrilaterals. And we also had a circle as well and its properties. Remember, we talked about when you're dealing with these shapes, it's important with your children to always reflect on their properties, because it's the properties that differentiates them from the other shapes. For instance, it's the properties of a square that differentiates it from a rhombus when we're looking at the angles and so on. So I hope you remember that. So we did discuss a circle, its properties. It must have a center, the distance from the center to the circle, the radius, as well as the distance from one end of the circumference to the other end through the center, the diameter. All those are parts of a circle that you ought to talk with your children. So that's two-dimensional shapes. Then we also talked about three-dimensional shapes, and in this case we talked about the cylinder, we talked about the sphere, we talked about the cone, and all these shapes we talked about their properties. We talked about how to calculate the area, how to calculate the volume. We looked at prisms as well, triangular prism, rectangular prism. We also looked at, and the most important point to remember here when we're talking about prisms and also pyramids was that the names are derived from their base. So a triangular prism is because the base is a triangle. A square pyramid is because the base is a square. So we did talk about these different three-dimensional shapes as well. So now, these three-dimensional shapes, when it comes to Euclidean geometry, are called solid geometry. So under solid geometry, therefore, we talked about the three-dimensional shapes and their properties, and under plane geometry, we talked about two-dimensional shapes and their properties. So then, today, let's look at transformation geometry. Transformation geometry really is the geometric outlook of the shape that leaves its change. What did I say here? This is a geometric outlook of a shape that leaves it changed. Okay, it's a geometric outlook of a shape, how it is left how it looks like after it's been either changed in its location, its orientation, or its size. What do I mean by that? So if we have any shape here, for instance, we might have, say, a triangle. If we have a triangle here, why are these shapes moving now? If we have a triangle here then, so then I was saying if we have a triangle here and there's my triangle, if I transform it, it means I'm going to change it. If there is no transformation, the triangle will remain exactly as it is. So what we mean here by a geometric outlook that changes either its location, orientation, or size means if I'm going to change this triangle, either move it to another position or make it bigger like that, then I have performed in mathematics what is called a transformation. So since this is a geometrical shape, what I have done, therefore, I have transformed it geometrically. That's what we mean by that. So for a transformation to take place, there has to be a shift either in the location, the orientation. In other words, as it is standing there, I probably redraw it and it looks like that. I've changed it in orientation. It is now facing a different direction, except the fact that it is still the same one, but I've changed its orientation and the size also. So when any of these happens, then we are dealing with what is called transformation geometry. So then, within transformation geometry, the shape can be transformed in many ways. It's either it can be ridged or non-ridged. Now, what do we mean? A ridged transformation leaves the size of the shape unchanged. So that means if this was my shape, if I'm going to transform it in such a way that it remains exactly the same way it is, then it is called a ridged transformation. So if I move it to this side and redraw it here, like that, exactly the way it looks, then it is called a ridged transformation. A non-ridged transformation is if I have my triangle here and I move it to there. Now you can see, one, I've changed the location indeed. Okay? So it is a transformation because I've changed the location. But I have also changed its size. It does not look the same size anymore. This has been enlarged. So an enlargement is a non-ridged transformation. That transformation that I did earlier where the triangle remained exactly the same size is regarded as a ridged transformation. So then, let's look at 4 types that we teach at primary school. 4 types of transformations that we teach at primary school that are ridged. Now, the first one we talk about is a translation, which is also known as a slide. We're going to talk about translation today. The other one that we talk about is a reflection, which is also known as a flip. The other one is a rotation, which is also known as a turn. And the other one is a glide reflection, also known as a combination of a translation and a reflection. So these 4 are regarded as ridged transformation. Why? Because when we operate on them, either change the location, the orientation, or we don't do the size. So we only operate on them with 2. It's either we change their location or their orientation, but we do not make adjustments to their size. Therefore, they are called rigid transformation. We would have called any transformation that works on the size of the previous. Now, in geometry, especially transformation, when we're dealing with transformation, the shape that we have at the beginning is called the object. The object. And the one that we get after a transformation is called the image. So we should just remember that. I will be reflecting on it in the next slide. So then let us look at what we're going to talk about today, which is a translation. So a translation transformation, to translate in mathematics basically means, and I think linguistically, means translation means moving. In other words, a translation transformation is a moving transformation. This is a type of transformation where every point moves in the same direction and also, rather, the same distance. It moves the same distance and in the same direction. So every point moves, but remember it is a rigid transformation, so there's no enlargement. Therefore, it means every point of the shape is going to move and will move in the same direction. So let us start with, let us say we had a triangle here, like that. And we call these points A. This one will be, say A, that's B, and that's C. If we are going to translate it in this direction, so we have the direction. And what about the distance? We need to specify. This is also regarded as displacement. Displacement. We need to specify the displacement. We need to specify the displacement. In other words, how many units has it moved in the other direction? So let us say it moves 2 units. So that means every point must move 2 units. So it's a translation 2 units. 2 units to the right. That's our transformation. The name of a transformation is a translation 2 units to the right. So if we are going to translate that triangle, let us call it triangle T. It is going to form an image which will be T prime. How many units? It's 2 units. So everything is going to move 2 units. So let's say that's 2 units. So this will also move 2 units. So A will also move 2 units to A prime. So this will be now A prime. B is going to move 2 units. 2 units to there. So this will now be B prime. The image of the point is regarded as a prime. So then C is also going to move 2 units. So let's see. It's 1 there, 2 just about there. So that will be our C prime. Therefore, this then is our triangle T prime. It has undergone a translation of 2 units to the right. 1, it has a distance. What is the displacement? 2 units. 2 units. What is the direction? To the right. So every point moves exactly the same units. So that line there has moved to that, exactly 2 units. That point there has moved to there. Therefore, this is the image of T prime, is the image of T after translating it 2 units to the right. I hope that makes sense. So we have translated T, triangle T, 2 units to the right, and that becomes its image. After undergoing the transformation, what was the transformation? It was a translation of 2 units. That's the distance. In which direction? To our right-hand side. Now, the next part, therefore, let us say this time, we now have, let us use the Cartesian system. In a Cartesian system then, in a Cartesian system we'll have to have right. So then in a Cartesian system then we have that the x-axis and the y-axis. So let us have some units there, and this is, we need to label our system. This is the x-axis, and that is the y-axis. Now let us say we had a triangle here with the following coordinates, which had that unit, that coordinate, which is 0, 0, and the other one was there, which is 0, 2, 0, 2, and the other coordinate was here at 1, 1. So our triangle, if we connect these 3 points, they would give us this triangle, and so that is our triangle. Now let us say this triangle now undergoes a translation of 2 units in the x-axis. So the translation is 2 units. Let me use another pen. The translation is 2 units in the x-axis. So that will be the direction of the translation in the x-axis, and it will be 2 units. So now, this is how we represent that. So we represent it as x, y is going to be translated, the values of x, the x coordinates will have x plus 2, because it's 2 units on the x-axis. There are 0 units in the y-axis, according to that. So therefore, it will be x plus 2, comma, y plus 0. Meaning, x, comma, y, when it is translated, it will be x plus 2, and the y coordinates will be y plus 0. So let us start with our A, and that's our B, rather A. I think let me have them as black, because that's what they are representing. Our A, B, and our C. So that means, therefore, when my A is at the origin, which is 0, 0, when it is translated in the x direction, this will be x plus 2. What is my x? 0. So it will be 0 plus 2, comma, my y is 0. So y is 0 plus 0, so it will be 0 plus 0. So my coordinate, therefore, will be x plus 2 is 2, comma, 0 plus 0, 0. My next, which is, this is now my A, and that becomes my A prime. Then my B is 0, 2. So this becomes the x, the values for x is 0, meaning that there has been no movement on the x-axis. On the y-axis, there's no movement on the x-axis, plus how many units on the x-axis? I'm there, plus 2 units. So it will be 2 units there. So plus 2 units on the x-axis. What about the y-axis? The y-axis, what is my value? Is 2 plus how many units on the y-axis? Plus 0. So therefore, my B prime will be 2 plus 0 is 2, 2 plus 0, 2. So my B prime will be equal to 2, 2. What about my C? C prime. My C rather is 1, 1. My C is 1, 1. After undergoing a translation of 2 units on the x-axis, the value of x is 1 plus 2, comma. The value of y is 1 plus how many units in the y-axis? 0. So this now becomes 1 plus 2 will be 3, comma, 1 plus 0 is 1. And that is my C prime. So these are therefore my new values of that triangle after it has undergone a transformation of 2 units on the x-axis. So what is my image now? A prime becomes 2, 0. 2 units, 0 is that. That is my A prime. B prime is 2, 2. It's on the x-axis 2 upwards 2. So it will be there. That is my B prime. My C prime is 3. So it's 3 units on the x-axis, 1. There. C prime. My new triangle now will be that. So that specifies my first coordinates. A prime is 2, 0. My next coordinate, B prime, is 2, 2. There. That's my B prime. A prime. My next coordinate, C prime, is there, which is 3, 1 now. This is the image after I have now translated my first triangle, that. After I've translated it through 2 units in the x-axis, that becomes the image. So that is how to represent it using the x-coordinates, and this would be regarded as a single transformation. This is a single transformation. So that's it, my single transformation, and that's how I arrive at an answer. So I would like you to probably try this one. Let us say you now have that. You have a triangle like that. These are the units. Again, it's a single label your systems, x-axis, x-axis, and that is my y-axis. Labeling them 1, 2, 3, 1, 2, 3. This is your origin, again, must be there. Your origin, 0. Now, my triangle is here 1, 1, 1, 1. The next is here 3, 1, and the next coordinate is there, which is 2, 3. So there is my triangle. That, my triangle T. Now the question is, find the image of T after translating it 3 units on the x-axis. That's question 1. I would like you to try this as well. Question 2, find its image after translating it 2 units on the x-axis and 3 units on the y-axis. Good. So let's try that. You are required, 1, we are given that triangle with its coordinates T, A, B, C. Let me probably label them as, that is A, B, C. You are given that triangle with those coordinates, and you are required, 1, to find the image of T after translating it 3 units on the x-axis. That's 1. 2, find its image, the image of the same triangle, after translating it 2 units on the x-axis and 3 units on the y-axis. So that this is called a double transformation. Just remember, question 2 is double transformation. So that means the triangle is going to undergo one transformation and then the next transformation. The final transformation gives you your the final image. Right, let's try that. Then next week or in the next lecture, we'll look at reflection. Have a good day.